go.
All right, good morning, guys. Welcome to week 3. Our lesson today is starting a new section, 7-3. We're doing the sum and difference formulas, and these are the two formulas over here we'll be using today. All right. Before we do the formulas, I want to come back over here and show you that a common thing that students think is true that's not is this situation here. This may look like it would make sense to you. Cosine of 60 plus 30 would equal cosine of 60 plus cosine of 30, but it just simply isn't true. Cosine of 60 plus 30 would be cosine of 90 degrees. That would be 0. Okay, it's supposed to equal cosine of 60 and plus cosine of 30. Cosine of 60 is 1/2, and cosine of 30 is root 3 over 2. And if you've forgotten all those, you should probably look at your unit circle sheet or have that out when you do your work. These are definitely not equal though, okay? So these formulas actually do like really complicated, hard work, but they're not hard for us to use really, okay? All right, this is our usual setup here. That was problem 1 I'm gonna do for you. You have number 2, I'll do 2, you'll have 4, and I'll do 5, and you have 6. 1's gonna be really easy. 2 is all of our precalc work that I've taught you. You'll see it all coming back, okay? And then number 5 is pretty easy, but this is where our work's gonna be today here, okay? All right, let's start with number 1 though. Okay, here it is. Cosine of 57 degrees times cosine of 78 minus 50, sine of 57 times sine of 78. All right, that's one of the cosine formulas. Notice it starts with both cosines and not sine and cosine. Okay, also when you look at the formula, it's really easy to make a mistake here. If that's a plus, the cosine formula is a minus. On the sine formula, if it's a plus over there. So the actual sign stays the same in the sine formula, and cosines even in this, but you got to switch the sign in there, okay? Our problem's in cosine, we have a minus, so it'll end up being cosine of alpha plus beta. Okay, and alpha, if you notice, that's just the first angle in each one, and beta is the second angle. Okay, so in our problem, alpha, that's 57 degrees. And beta is 78 degrees. All right, and now if I add those two together, that is 135 degrees, if I'm not mistaken. And that's in quadrant 2, so cosine is going to be negative because it's on the left side. And cosine of a 45-degree angle, which is one of those, 135, is root 2 over 2. So that's our finishing answer is negative root 2 over 2. All right? Okay, again, grab that unit circle if you're getting rusty on it. Okay, problem number 2, much more complicated, okay? Not hard, should be really familiar with the things I'm going to do here. Sine of alpha is 5 over 13. It's in quadrant 1. That kind of tells me that I need to draw a picture and put a reference angle, like a triangle in quadrant 1. I have to do the same for angle beta over here that's in quadrant 2. Okay, and then we're going to do find cosine of alpha plus beta. We're just going to be plugging it into this formula up there, so it won't be very hard, okay? All right, here we go. Okay, all right. For alpha, this is my setup for alpha. Alpha, it's in quadrant 1. And sine is 5 over 13, that's the opposite over hypotenuse. 5 over 13. Okay, I would do Pythagorean theorem here to find out my x value. X squared equals, x squared plus 5 squared equals 13 squared. Okay, and x ends up equaling 12 in this problem. Okay, so I have my value for sine there. It's also, I have to note that it's positive because it's heading that direction in quadrant 1. Okay, tangent over here is equal to negative 24 over 7. That's opposite over adjacent. That's 24 over 7. And the negative, you might think it's on the 24, but the x is the one going to the left, so that's where the negative value is. Okay? All right, in this case, I'm going to find my hypotenuse. We'll call it c here. And this would be negative 7 squared plus 24 squared equals c squared. And 25 should be the answer you come up with. All right, so I'll put those values on here. And this one is 12, okay? And now we're just going to insert these things into our formula. Cosine of alpha plus beta. This would be cosine alpha, cosine beta, sine alpha, sine beta. I'm going to write that out. Cosine alpha, cosine beta, and then I have sine alpha, sine beta. Okay, that's a plus, this will be a minus in there. Okay, and now I'll substitute the values for each one. Alright, okay, cosine of alpha. So here's alpha, our triangle's labeled, we want cosine. It's going to be adjacent over hypotenuse, 12 over 13. All right, next value is cosine of beta. Come down here, cosine of beta, again, opposite over adjacent over hypotenuse, sorry, negative 7 over 25. Okay, now we move on to sine of each function. Sine of alpha, they told us that in the beginning it's 5 over 13, but it's opposite over hypotenuse. Okay, sine of beta, come down here, opposite over hypotenuse, 24 over 25. All right. Okay, conveniently, these end up having the same bottoms, which gives us the same common denominator, which is helpful for us in our problem. 12 times 7, that's going to be negative 84 over 325, I believe, minus 5 times 24. Think of what that value is there. That is 120. 120 over 325, and then I just have to do this math. They're both minus, so I'm going to join them together. That's negative 204 over 325. That's my answer right there. Okay? All right, let's think about what we did. Watch what we really did. This is my angle alpha, this much, however much that is, and then I'm going to add beta to it and end up somewhere over there, and that new angle, alpha plus beta, if I knew it, then I can find cosine of that angle. It would be negative 204 over 325. So that's pretty complicated work it's doing. So we're able to find that even though we don't know how big either of the angles are. Okay? All right. Again, set up a circle for each angle, label it, put it in the right quadrant. That's really where you guys go wrong. Okay? And then get your values and you just substitute in the equation. You should be okay. All right? Come on over to number 5 for me. Okay? Find the exact value of cosine of 15. You guys know that when I say the exact value, it means no calculators, okay? 15 is not one of the angles we know, so like I can't do that normally, but we're going to go ahead and use our formulas that we have and be able to do that, okay? It's sine. I'll be using the sine formula here, okay? And I need to create 15 degrees out of some other angles to use that formula. So my first one I put up here as a suggestion would be 75 minus 60. That would equal 15 degrees. That would be okay. The problem with that is when I go to plug it in here, it's going to ask me to find sine of 75, and I don't know that value. Okay, so that's not one of the ones we know. So these guys here, any ones you choose, they should be an angle that you know the values of. So this is not a good choice for us. I would not be able to do it. 45 degrees minus 30 degrees, those are two angles that I know the value of both those angles. That's a good choice. That equals 15 degrees, and I can use my substitute in here and do that problem. So let's go ahead and do that. All right. Notice I have a minus here in my sine, so it'll be a minus over there. Okay, and it's going to be sine of alpha. I'll write out the formula again. Sine of alpha, cosine of beta. Again, that's minus. This will stay a minus for that. And then it's going to be cosine of alpha, sine of beta. Okay? All right, here we go. Sine of alpha. Well, alpha is 45. So I have sine of 45 degrees. And then cosine of my second angle, which is 30 degrees, minus cosine of alpha, cosine of 45, my first one, and sine of 30. Running out of room over there, okay? All right, and these are multiplied together over here as well. Okay, sine of 45. Root 2 over 2. Again, if you're resting on that unit circle, pick it back up, take a look, and you can keep it out while you're doing your work. Cosine of 30 is root 3 over 2. Remember that we start with sine of 30 is 1/2, so cosine of 30 has to be the other one, the root 3 over 2. Minus cosine of 45. Remember, all the 45 sine or cosine are all root 2 over 2. And sine of 30 was our very beginning angle I taught you, 1/2. Okay. Again, they have a common denominator already, which is good. This is root 6 over 4 minus root 2 over 2. Whoops, over 4. And that'll be root 6 minus root 2 all over 4. And you cannot cancel here for a number of reasons. They're connected by plus or minus, and these are inside the roots, and that's not, so they'll never cancel. Okay? All right, also, last thing before I let you go, we'll have assignment for this week. I'll be adding some more, but these are the problems that you can do so far. So anyways, hope you're having a good rest of your day, and I'll talk to you soon.